Mars was once alive with rivers, lakes, and a sky thick enough to sustain a very different world. Today, it is a frozen desert, a planet stripped bare beneath an unforgiving sky. What happened? For billions of years, an invisible force has been relentlessly attacking Mars. A constant stream of charged particles from the Sun, known as the solar wind, has been tearing away the planet's atmosphere piece by piece. As that protective blanket disappeared, Mars lost its ability to hold liquid water on its surface, transforming from a potentially habitable world into the barren landscape we see today. But how did this slow planetary collapse unfold, and what does it mean for the humans who may one day walk on Mars? NASA's newest mission, ESCAPADE, short for Escape and Plasma Acceleration and Dynamics Explorers, is setting out to answer these questions. By observing how Mars responds to the solar wind in real time, scientists hope to finally uncover the missing chapters of the planet's dramatic climate history. For the first time ever, 2 spacecraft will orbit Mars together. Until now, every mission sent to study the interaction between the solar wind and Mars relied on a single spacecraft. That meant scientists could only observe one location at a time, making it difficult to understand how events unfolded across the planet. ESCAPADE changes everything. With 2 spacecraft working in tandem, researchers gain something they've never had before, a true 3-dimensional perspective. Instead of isolated snapshots, they can watch the same event unfold from multiple viewpoints simultaneously, revealing details that were simply impossible to capture before. The twin ESCAPADE spacecraft fly in 2 carefully designed orbital formations, each created to reveal a different side of Mars's battle against the Sun. The first formation, known as the String of Pearls, places both spacecraft in nearly identical, highly elongated orbits, with one following closely behind the other. This setup allows scientists to witness rapid changes in the Martian atmosphere as powerful bursts of solar wind slam into the planet. With the spacecraft passing through the same regions only minutes apart, researchers can detect atmospheric changes occurring in as little as 2 minutes, extending to roughly half an hour. Previously, those same observations required waiting anywhere from 4 to 8 hours, leaving many of the fastest events completely hidden. The second formation tells a different story. Here, the 2 spacecraft separate into distinct orbits. One ventures farther into space, directly sampling the incoming solar wind before it reaches Mars. The other remains much closer to the planet, measuring how the upper atmosphere reacts to that incoming energy. For the first time in history, scientists will be able to observe both the cause and the effect simultaneously, watching space weather strike Mars as it happens. ESCAPADE is about far more than solving one of the solar system's greatest mysteries. Its discoveries could shape the future of human exploration on Mars. One of the mission's major targets is the Martian ionosphere, a charged layer high above the planet that future astronauts will depend on for communication, navigation, and mission operations. Unlike Earth, Mars offers far less atmospheric protection, and its ionosphere constantly shifts under the influence of the Sun. By understanding exactly how those changes distort radio signals, scientists can design more reliable communication systems for future crews exploring the Red Planet. But communication is only part of the challenge. An atmosphere also serves as a planet's natural shield, helping protect everything on the surface from dangerous solar storms and high-energy cosmic radiation. Since Mars has already lost most of that protection, understanding what remains and how it changes is critical for designing habitats, equipment, and technologies capable of keeping future astronauts safe. ESCAPADE is also rewriting the rules of how spacecraft travel to Mars. Traditionally, missions have been forced to wait for rare launch windows when Earth and Mars align in just the right positions. Missing that opportunity can delay a mission by more than 2 years. ESCAPADE takes an entirely different path. Instead of heading directly toward Mars, the spacecraft will first travel to a distant region of space near the Sun-Earth L2 point, roughly 1 million miles from Earth. There, it will wait patiently before swinging back toward our planet, using Earth's gravity as a powerful slingshot to accelerate toward Mars. This innovative trajectory allows NASA to launch much earlier while still arriving at Mars at exactly the right time. Along the way, Escapade will accomplish another historic first. Before beginning its 10-month journey to the Red Planet, it will become the first spacecraft ever to pass through one of the most distant regions of Earth's magnetotail, the enormous extension of our planet's magnetic field that stretches millions of miles into space. Escapade is more than another Mars mission. It is the newest member of NASA's growing heliophysics fleet, a network of spacecraft studying how the Sun influences every corner of our solar system. By adding simultaneous measurements from Mars, scientists will gain an unprecedented system-wide view of how space weather travels across interplanetary space. Because understanding the Sun isn't just about explaining the past, it's about protecting the spacecraft we build, the technology we depend on, and the astronauts who will one day venture farther from Earth than ever before.